Oh, I'm getting that nice mama. I'm gonna get my gimbal set up ahead of time this time. I'm sorry. 3 minutes. Still is. I mean, I won't be able to take it well. I just have to put it right now. I do want to make this mix up. That's nice. No carding camera. Fix that problem. No card in the camera. You fix it by putting a card in the camera. I don't know how old the battery is. Find that. Okay. Got 4 bars. Yeah, that's gonna work. I put my backpack away in the back here. Gopher. Gopher.
Yeah, you sound sounds you sound the same as first time.
Yeah, that's wait, so there's consequence of time.
This was the response that was like so
Get it.
yeah, yeah, it's so you're trying. All right, welcome everyone. We're gonna get started with the Unveil presentation. So, all right, so we are opening with our sales. We have stuff to unveil here. You guys were there for our other unveil. Then we can start. All right, so we works with leadership. So we break up into two sets of prime routes as well as our sub team leads. The front races are myself, Ben, Mike, audience, and Rafa. So we do a lot of the work leadership type stuff. And each of our sub team meetings kind of goes all of the specifics to the sub teams. And there's a rough breakdown of our team members. So as always, we're typically mechanical engineers. We also have a lot of aerospace engineers. Last couple of years, it's been growing the last couple of years, especially as we've had PD car. And our team is overall very young, probably as a result of COVID. We haven't had a lot of older classes. So with all these new freshmen, sophomores coming, seems to be true.
So, FSAE is a student design competition organized by Society of Automotive Engineers, where students design, build, and test race cars by interesting rulebook. And it's a competition that happens every year. We go to 2 competitions every year to determine professional we like for one. And our competition this year is going to be in about 2 weeks. Why did we love our FSAE? It's an open place for any students with any backgrounds, majors, and we are all here to learn and prepare for industry, compete, and have fun.
So I'm gonna start with the brief overview of the competition. So we compete in what are called static and dynamic events. The dynamic events are the car will drive the car and there'll be scored based on the performance of our car, and then static events in which we perform or graded scored on the design of our the knowledge of the team, skills of the team. The first event I'm going to talk about static event, it's called the design event, and we talk to fresh engineers about the decisions we made in designing the car, and we're scored based on how well we're able to justify this. The next event is also static events, it's cost events, so we are scored based on the cost of our vehicle. So we'll explain to FSAE how we constructed our car, what materials we made it out of, what processes we used. We're scored based on the cost of that, those processes and materials. And then we're also given a cost scenario where the team will be assessed on our knowledge of if we were to have to pivot, how we manufacture our car, how well we would be able to. The last static event was the presentation event, and this is assessing the team's business skill capability in the events that we would have to pivot in an economic scenario. We're given an economic scenario. The team is assessed based on how well we're able to make good decisions in that scenario. So the first of the dynamic events is the acceleration event. This tests the car's straight line acceleration at 75 meters straight. We're assessed based on that time. The skip down events test the car's cornering ability. So we'll do 2 loops to the right, 2 loops to the left, and test the car's cornering ability, symmetrically to the right and the left against scored those. The next event is the autocross event, and this tests the car's acceleration and cornering in a track. So we're given a track, set of at Michigan International Speedway with cones. And the car will be accelerating, cornering, and it's usually a 30 to 60-second track. And the driver gets to walk at once. Then we'll get each driver. We have 2 drivers for this event. We'll get 2 attempts. We get 4 attempts at that event. And then finally, the big event is the endurance and efficiency event. These are scored together. So the endurance event is a 20-kilometer race. We have 2 drivers that drive that event. Driver swap to between. And then we're also scored on how much energy we use while competing in that event. And that's 375 points after one bicycle event. So it's very significant. So talking about some previous vehicles, this is only the team's 3rd electric vehicle. So back in 2022, our first electric vehicle, we didn't do too bad. We placed 19th. Unfortunately, the vehicle was not able to drive, but we learned a lot of lessons. We took those with us into 2023, where we made our first driving electric vehicle. We did extremely well. We were able to place 7th, and we're continuing to learn and go to do well this year. So talking a little bit about the previous car, just to give you an idea of where we're coming from. We previously had a steel space frame with a carbon fiber suspension, and we had our first ever aerodynamics package last year on our electric vehicle. We run a MRX 208 medium voltage liquid cool. We designed a lot of custom electronic modules in the house. And then last year, we, like I said, we achieved a 7th overall finish. We placed 4th in the 52, so we did really well there. We placed 4th finish, and we placed 5th overall in endurance. As far as goals for this year, we're aiming to maintain a top 10 finish. There's a lot more competition coming into EVs, the EV space, and FSAE. So we're aiming to maintain the top 10 status of the team. And this year we're focusing on system understanding, testing, documentation. Last year, we didn't have as much test time as we wanted, and the vehicle didn't perform its full capacity, so we're hoping to change that this. In terms of points goals, largely looking at our points goals this year, we took the fact that we wanted a top 10 finish. We looked at roughly 100 points we need to get that, and then we assessed roughly where we're going to land in these events I just talked about. So unfortunately, our vehicle is going to be a bit more expensive this year, so we're suffering a bit in the cost of the change and the efficiency scoring. So a lot of teams are going to score much lower this year, but that's the cost for all teams. So that will impact us as well as other teams. You can see our skip match score improved quite a bit there. Like I talked about earlier, unfortunately, we can have some testing times we would like. So with more testing time, you can get a much better skip match score. We weren't able to, like I said, are we running in the performance what the past that? Talking a little bit about the vehicle, this year we switched to a hybrid monocoque. We redesigned our accumulator using aluminum instead of steel. We're using pouch cells instead of cylindrical 18650 cells. Switched to a DTI 8550 inverter from our previous cascading motion inverter. We redesigned our wheel well suspension to use almost 4 pounds. We were running a live telemetry system. We have a electronically activated servo-driven brake reduction system. We have a custom vehicle control unit that we designed in-house, along with a bunch of other electronic modules, and we have an updated aero package to contribute to the vehicle. Then we're going to jump in here to an overview of the different sub-teams on the team.
Yeah, so I'm Wyman Parkey. I'm the business sub-team lead. The business sub-team is really in charge of reaching out sponsors, getting sponsorships, helping out the university. And as far as the competition, as Ben mentioned, we make the business presentation. This is kind of a business scenario. This year it happens to be we had to pitch non-solely electric-based drivetrain, and we just presented this actually yesterday. And then we also do the cost scenario and the cost event, and that is typically more like how do we reduce the cost of the vehicle. For this one, it was how do we reduce the cost by 5%.
A lot of really cool design effort happened on electrical this year. There's a lot of things that were shared with our internal combustion car, including this new live telemetry system, which worked extremely well at our competition. But on this year's car, we now have a new, we designed a new custom 550 volt to 13 volt DC-DC converter. which is a very large design effort intended to save a lot of weight and the amount of battery pack we would require to do that. Otherwise, we have a new steering wheel module, which is shared with the internal combustion vehicle here. We switched, as I mentioned, we switched to a new GTI HD550 inverter. So we had to do some design effort to communicate with it and test it ahead of time. And then also all of our custom PCB control modules had improvements, just other small changes made, including with the controlling unit. Now has our tracking system active light required circuit by rules instead of a module solely in the accumulator last year. We increased the amount of voltage sensors that our sensor hubs support. And a big thing was we can software control what sensor types we connect to it. We'll just with this other thing, so that's a very high convenience improvement. We now have high-speed USB on both our power and logging module and our telemetry module, which are two data logging modules. We have two for redundant data logging too. We now have that, which pulls data extremely fast from them. We have the steering wheel module for driver control. We also did big efforts to standardize module sizes for our vehicle control unit and sensor hubs are both the same size, as well as the telemetry boards. We can design one enclosure or make similar modifications to that enclosure. For other ones, we have standard enclosures, and because of that, status LED colors, I would say, just take a look at the module and understand what's going on. How many circuits were standardized, and mentioning the brand new 5-part wire harness. We went to from last year doing 2 sensor hubs to now 3 sensor hubs, 2 in the rear and 1 in the front. Just to make it very easy to connect new sensors if we would like to. This wire harness was designed very robustly. I'm very confident in its ability to be reliable. Just put a lot of effort in that.
Yep. Okay. So on the powertrain side of things, like Ben mentioned, we did a full accumulator redesign this year. So the accumulator is our battery pack that powers the car. And the biggest thing, the reason we had to fully redesign it was because we changed the type of batteries we're running. So last year we were running cylindrical cells, which look exactly like you imagine, like what you'd pop into a TV remote. I mean, they're kind of bigger, but we changed to pouch cell batteries. Pouch cells are, you've never heard of a pouch cell before. I think they look like unopened parts. I know, but and the reason we made this change is because pouch cells have one, they were free, they were donated by Tesla, thank you very much. And 2, they have a much lower internal resistance. Internal resistance in a battery is generally directly correlated to how much heat the battery produces. So that was a big decision factor because less cooling we have to do that. And then we upsized our pack voltage this year. So last year we ran, 52 volts. This year we are at about 550. And this just gives us more flexibility. So like in the future, we wanted to increase the number of motors that we wanted to run. We would kind of already have the voltage to do this. We would really need to make a lot of accumulator adjustments to do so. And then like Ben said as well, we changed from steel to aluminum. And even though aluminum has to be a lot thicker by rules, we still save weight. Sound great? As far as battery cooling, like I kind of mentioned, last year, battery overheating was one of the main reasons we had to really dog the car in endurance. So for the electrical competition, there is something in the rules that says if your batteries at any point hit 60 degrees Celsius, your car has to shut. And unlike the IC competition where, yeah, like your engine can hit any temperature you want, just as long as it doesn't blow up, this competition, you really, really, really have to be on that because if at any point it gets overheated, you're done, it's off, and you can't maybe even endurance event. So this year we integrated airflow cooling channels kind of in between each of these cells. Here you can kind of see that. And then there's a fan down to the top of it that was down each segment has its own fan. Whereas last year there were 4 fans, this year we had 8. So yeah. Another huge change that we made was we integrated the drivetrain with the motor mounting. So another big problem last year was the motor was kind of just supported on one side by singular mount. And we were seeing that at high load, the whole motor arm was kind of flexing a little bit, which is something you don't want at all, not even the slightest. So we made the decision to integrate the motor mounting with the uprights that hold the differential. So when we with the curtain off, you'll see it's all one combined piece. It looks very pretty. This is lighter and now chain alignment. It's really easy. It's guaranteed. Yeah.
So I am not kind of rolling here now, so controls it. The ergonomics controls sub-team is essentially the driver sub-team, so the driver interacts with. Pretty much it's our job to implement the steering wheel, steering system, seat, pedal box for brakes. Some of the really big change we made, we switched to the analog button. It's the sexiest design change ever, but hopefully it will increase our reliability. We also did a lot of work to reduce both our understanding and mass of the brake orders. And as well as just a lot of functionality improvements like the new steering wheel. Has more buttons, so let's work on top of that. As well as change the pedal box.
All spanner on the first suspension unit. So this year, kind of one of our goals, is to just sort of, get a lot of new stuff. Basically, the last 2 years, our EV was basically the same frames our 2019 C. And that worked great when we just tried to put the car driving and make sure it passed that. But, now we're actually trying to push to have a car with a lot better performance. So we went ahead and made the suspension the same across both cars. It was a big update for in terms of the new kinematics, new suspension, switching from pull rod in the front to a push rod in the front, suspension system. And also we did some same with the IC, we ran cells and old suspension, and we did data on a set of road cases across all the different driving conditions and driving conditions. And so our suspensions are driven through a ton of good data and also ran kind of testing on different carbon tube sizes to optimize those for increase slot. MTS and other sponsor of ours, they were able to let us use the heat test work so we could get the fatigue testing for the driving carbon tubes to make sure they're not going to fail. Right, so that would have had a most full positive suspension. Also, Ben mentioned a little bit when we want to skip that time. That was a good problem for LCs, that's a good problem for TV. We don't have the intention radius, so we changed some of the pneumatics points for the steering system, so we should have a little bit, a little bit higher in the steering torque, so we have to work a little harder, but that's fine. Sure. Hopefully you'll be able to go faster and skip that. So yeah, also in addition, there was just some better structural things that we were able to run, optimize the side and some to make sure we weren't going to push our things. Also to look at things from a system level, about that so things more than just individual points. And yeah, like Ben said, also we switched to a monochrome, and we pushed on a little bit of and so that's just another part for us to kind of put in mounds of the media gain out the monochrome to keep that moving forward. Hopefully we don't need to another time.
I'm Spencer. I'm not the air lead, but I'm filling for Gavin for today. So some of the big design choices we made for aerodynamics this year. We really wanted to focus on overall car performance. Last year, like I said, that was our first time doing a aero package for the EV, so we were really focused on efficiency and just getting aero on the car. So this year we did a full aerodynamics redesign with much more aggressive front wing, well as adding in the third element to the rear wing. Sticking with the rear wing, we also added a drag reduction system, also known as DRS. So what that basically means is that the last two flaps on the rear wing will go down to reduce the drag of the car. So overall, when the DRS is activated, the car decreases its drag by 44%. under no load, it actuates in 80 milliseconds. And we anticipate that over the course of endurance, we should save 1.2 kilowatt hours. So yeah, overall, much more aggressive aero package, about 50% increase in downforce compared to last year. So much better quartering capabilities, which will help a lot in the dynamic development. Of course, another thing also about air sponsors, we receive a lot of funding from the university as well relates to parts such as monetary donations, as well as in some cases on the hospital. So with that, let's get to the end of it. Okay, thank you to everyone who came, everyone who attended in person and virtually. We're happy to answer questions. So we have donuts over there if you're hungry. But we're happy to answer questions about the car. So please come talk to us, take a look at the car, and thank you for coming.
Your dad or what? Yeah, I like that one better. So, I mean, that one's cool too, but I'm not hyping in favor of the first one. Yeah, that's sweet. If you if you think you heard people, oh yeah, I really like that one. Okay.
See if we can get it up close. If you don't mind, I'm just gonna put it closer. Okay. You guys move mine a little to the side for the camera. I do like, and then like
That's gotta be like Walt Disney. What's that usually called? Yeah, you guys all said that. Like it's half started. Just making sure. The first episode, honestly, I want to get some justice. No, I'm gonna watch it.
We're actually going to see it in the live stream. It's not wrapped up. But on the IC one, we unveiled it. It was just staring at the back of the wing, and then the position never changed. People just crowded around it, so you couldn't even see it. I actually got my camera rolling.
But that is still like,
The shutdown circuit is massive. 11 things. There's more safety. It is something, yeah. But these stops are probably all these stops. The lower one is your low voltage power. The other one is your I mean, you have to put a key in there and turn it to allow the car to you can't, it's a lockout takeout thing, you can take out the key if you really needed to. You can like take the key with you and stop anybody else from turning the car. One of the points of that. Basically, they wanted to then somebody could stop the car from driving, like someone like an ESO or somebody, when they leave and make sure nobody jumps on the crosswalk. That is just part of the shutdown circuit. In the shutdown circuit, you need the full shutdown circuit. That's how you turn the car. That allows, I don't want to say it turns on the car because it doesn't. If anything else is there, so that all current is over to the so that nothing. I'm putting my foot down. The shutdown circuit being open